All right, this part of your lecture is what we would have done on Zoom for Chapter 10 together using Minitab to do hypothesis testing, which is what really we focus on. All of Chapter 10 is just looking at two hypotheses, two different samples and comparing them, because most of the time we will be comparing multiple statistics. And we will give an example on looking at just a single hypothesis test. You can see if you click on basic statistics, you can do a one sample Z or T. Again, the same information that we would have looking at a sample that had a comparison mean that we wanted to test against. And we'll also show the two sample T. We'll talk a little bit about the difference between pooled and not pooled, and then also a paired T. So we'll look at a couple of these things and how we can use them now. And so the first thing that I want to do is, if you are given information that is just given to you, where you already have all of the information in front of you and you don't have to calculate anything, you don't need any data first to calculate a mean or standard deviation, that you're working with summarized data, you can do the testing for that just as easily. And so we're going to start looking at those by looking at our first exercise, which will be involving data that has been given to us, and we're just going to run the test. And so the first question that we have, we're going to use stat basic statistics. We're doing a two sample t-test here, and the information tells us that we're comparing summarized data. And so we're asked for a sample size and a sample mean and a standard deviation. And so our sample size for our first sample was given to us as 10, and our sample mean for that first sample is 4.7. And then our sample standard deviation is, let's see, standard deviation is 10. And then our second sample, we had a sample size of 15. We have a sample mean of 7.8, and we have a standard deviation of 5. Then we're told that we want to test this against an alpha of 0.05. So this confidence level of 95 is exactly what we're looking at. And we're looking at a null hypothesis that there is no difference between the two sample means, and the alternative hypothesis is that there is a difference. We do not have equal variances, and so we're not going to check that box. And so we hit OK for those options, and we hit OK on this box, and up pops the result. And so we see the descriptive statistics immediately, which is what we put in ourselves. And then down here is what we're looking at. The test itself, we have a null and alternative hypothesis. The difference is equal to 0. The difference is not equal to 0. A t-value, the degrees of freedom for that specific test, and a p-value. If you remember, our t-tests have a couple different ways of calculating the degrees of freedom, depending on if it's a paired t-test, a pooled variance, or a non-pooled variance. So our degrees of freedom for a two sample test are not as simple as our degrees of freedom for a one sample test. It's not just n-1. We actually have to be a little more nuanced in that, but using Minitab, we don't have to do those calculations at all. And so what we're really concerned about is the p-value. And we remember that if the p-value is greater than our alpha, so our alpha was 0.05, because we're looking at a 95% confidence interval, and if our alpha is 0.05, then we're saying that if the p-value is greater than 0.05, we're going to accept the null hypothesis, and the null hypothesis says that there is no difference. So based on those sample sizes and standard deviations, we're saying that there is no statistically significant difference between the means there. Now, we're going to look and do this with actual data now. And just to show how this works, we can click on these boxes and delete them so that we can clear up our screen here and they can just go away. I'll show you a few other features in a minute, but let's go ahead and run the next test. So the next test, we're going to do a 2-sample t-test, and we're going to now, instead of do summarized data, we're going to say that each sample is in its own column. And so sample 1, you see as soon as I click in that sample 1 box, I've got all of my columns choices. So machine 1 is going in sample 1 box, and then machine 2 is going in my sample 2 box. My options are still, I'm looking just to say, is there a difference between machine 1 and machine 2? This question is also looking at a two-sided, so an alpha of 0.05, two-sided hypothesis, so equal to or not equal to. And again, we're not going to assume equal variances because the question actually tells us that they don't have equal variances. And so we're going to go ahead and run this test. So we say okay, and we hit okay. So at this point, now here, I didn't have summarized data, so the descriptive statistics is something they've now calculated for me really quickly. So my mean, my standard deviation, the standard error of the mean, these are all the really important features we've been focused on as we do hypothesis testing. That mean, the standard deviation, your n, your standard error of the mean. This has been very helpful in calculating alpha and beta. It's helpful in calculating our confidence intervals. So those are really important things. And like you'll see for your case study, it's helpful because the test is summarized here, where it gives you the null hypothesis and the alternative hypothesis. It's calculated the degrees of freedom for a non-pooled variance, so it's done that calculation for us. It gives us a t-value and it gives us a p-value. And so again, we're looking here, the p-value is greater than 0.05 because our 95% confidence interval on the mean is 0.05. And so because 0.435 is greater than 0.05, we are going to fail to reject the null hypothesis, or in other words, we are going to accept the null hypothesis. And so since we accept the null hypothesis, we are saying that machine 1 and machine 2 function similarly, or statistically, they are not different in their function. So even though their means are different, even though their standard deviations are different, this test shows us that there is no statistically significant difference between machine 1 and machine 2. So another thing you could do if you wanted, you could look at that t-value and compare that to the t-value in the textbook. And so looking at a two-sided test, excuse me, I'm sorry I sneezed at you guys. Came on too quickly for me to mute myself. So if you're looking at a two-sided test and you look at the t-table, so again, our alpha of 0.05 becomes 0.025, and at 17 degrees of freedom, 0.025, our t-value would be 2.110. And so as it says in our basic acceptance criteria, that when we're looking at the null hypothesis being equal or not equal, we're looking at that t-value, and if the t-value is greater than your t of alpha over 2, you would reject the null hypothesis. Well, 0.8 is not greater than 2.110. So again, we fail to reject, or in other words, we accept the null hypothesis. So you can see the conclusion for the test both from the t-value using your t-tables or your p-value compared to your alpha. And that alpha is what you put into the test and use for your confidence interval. So quick note, if I wanted to take this information and copy it into my homework, for example, I click on that box, and that drop down gives me a send to Word, send to PowerPoint, or just a copy or a copy as picture. And so when you're doing your homework or when you're doing your case studies, you can just take these individual boxes and copy them into your homework. Now, for the people using Wiley Plus, you can enter these numbers into those spaces in Wiley Plus. And yes, please feel free to use Minitab instead of doing all this by hand. Chapter 10, 11, and 13, absolutely do things with Minitab. Don't bother doing it by hand. I showed you how to do it by hand in the PowerPoint file, but you should be using Minitab. So the understanding of the formulas is something that is important, and that's why I cover it in lecture. But for all functionality purposes, your homework, your case studies, everything that you're going to be doing, your quizzes, tests, anything that you're doing, from this point on, you should be doing in Minitab. If you don't do it in Minitab and you do it by hand, you might be wrong. But you do need to show me that you got the information. So descriptive statistics, I'm almost always going to want you to go ahead and copy that and put it into the document. Sometimes I'll ask you for that 95 confidence interval on the difference between the means, and then certainly the actual hypothesis test itself, the null and alternative hypothesis, the p-value, the degrees of freedom, the t-value, all of that's very important. So I'm going to delete, well, actually, I'm going to leave it because you'll see that Minitab just keeps pushing it down when we do these. All right, so the next thing that I want to look at is this is an interesting problem that they give. They give a before and after, which means paired t-test. So the first thing I'm going to do is I'm going to go to a basic statistics paired t-test. And it says each sample is in a column. That's what I want, instead of summarized differences, because I don't have summarized data, I have raw data. So I click again in sample 1, and I have the initial weight. Select that for sample 1, final weight, select that for sample 2. Okay, so I'm going to look at this, and I'm just going to say, my question is, does sample 1 equal sample 2? Did they lose weight? Are these statistically significant? Are they basically the same thing? So the first thing I'm going to look at is at a 95% confidence intervals, I'm going to say that these two samples are the same. So I hit OK, but look here. Here's my descriptive statistics. Here's my 95% confidence interval. Here is the mean and the standard deviation and the standard error of the mean of the paired difference. These are the descriptive statistics, the mean and standard deviation and standard error of the mean of each of the individual columns, the individual initial weight column and the individual final weight column. This is the descriptive statistics for the paired difference. When you're doing a paired t-test, this is the box that matters. This one doesn't matter nearly so much. Paired t-test, I want the paired difference information. Now, the test, again, null hypothesis, alternative hypothesis. The null hypothesis is that the difference between the means is equal to 0. Alternative hypothesis is that they're not equal to 0. Well, looky here. P-value is 0. That is less than 0.05. So what does that mean? It means that I'm going to reject the null hypothesis. I'm rejecting the null hypothesis. I'm saying that there is a difference. And so in this case, that's good news because it means the people that did this weight loss program lost weight. As a group, they were statistically significant different in their final weight than they were in their initial weight. So in this case, rejecting the null hypothesis is a good thing. This is what I wanted to have happen. I wanted to see that there is a difference. And in your case study, you're going to be looking at a cost of energy, and you're going to be asking the question, did energy bills stay the same? Is there a difference? And it's a good thing sometimes for there to be a difference because it means you've made progress. So whether you're trying to lose weight or increase your your GPA or address something in like your habits and study skills, whatever that may be. If you're looking to see a positive or a negative difference in something, you want to reject the null hypothesis. You want to say that there is a difference. You don't want the null hypothesis to be confirmed. Okay, but we're going to do something even more fun with this. I know, you're all tingly inside, right? Instead of just looking at the paired difference and saying, okay, there's a statistically significant difference. Now I want to know, well, is it true to say that this program will help you lose at least 3 pounds? Can I say that and be statistically accurate? Well, what am I going to do? I'm going to do a 1 sample t-test. I've only got 8 data points, so I need to do a t-test. I'm doing data from a sample in a column, so I'm going to click on the difference column. I'm going to perform, I select that and move it into the box. I'm going to perform a hypothesized test, and I'm going to say that the hypothesized mean of this is 3 pounds. My options for this test, instead of saying that it's equal or not equal, I'm going to say that the mean is greater than the hypothesized mean. So I'm going to say that you lose at least 3 pounds if you do this weight loss program. So I'm looking only at the difference. I'm doing a t-test for just that one column. It's a hypothesis test with a hypothesized mean of 3, and it's looking that the mean of the sample is greater than 3. So I can say that people lose at least 3 pounds. Let's hit OK. Let's see what happens. Well, I get my descriptive statistics for 1 sample t. So I have my n is equal to 8 here, mean, standard deviation, standard error of the mean. I've got a lower bound only. I've got my test right here. My null hypothesis is that the mean is equal to 3. My alternative hypothesis is that the mean is greater than 3. So what do I look at here? 0.019. Well, 0.019 is less than 0.05. So I'm going to reject the null hypothesis, but that means I'm accepting the alternative hypothesis. You see what just happened here? My p-value tells me to reject the null hypothesis, but accept the alternative hypothesis. I'm saying that I can, with 95% confidence, tell you that this, based on this sample, this weight loss program will help you lose at least 3 pounds. So for all those weight loss claims that populate all of your social media ads, this is what we're looking at. This sample of 8 individuals had a mean weight loss greater than 3 pounds. And so I can say with 95% confidence that this weight loss program will help you lose at least 3 pounds. Well, I'm going to get greedy. Can I say that it's going to help me lose at least 5 pounds? 1 sample T. 1 or more samples, looking at the difference column, same column. Now I'm going to look at the hypothesized mean of 5 pounds. And so I look at my options. Still, I'm looking at the mean is greater than the hypothesized mean of 5 pounds at 95% confidence interval. I hit OK. What happened here? My p-value just jumped. My p-value is greater than 0.05. That means I fail to reject the null hypothesis. This program will not help you lose more than 5 pounds. I cannot say that, at least not at the 95% confidence interval. We're going to do one more and just say, okay, well, let's go back to that 3 figure that we had before. Again, we're looking at the difference column, performing a hypothesis test, but now I'm going to change that confidence interval. So if you have a problem that gives you an alpha of 0.01 instead of 0.05, all I do is I click on options and reset the confidence interval. And I can type that to be anything. So my alpha could be 0.2, and I'm looking at a confidence interval of 80. My alpha can be 0.1, and I'm looking at a confidence interval of 90. But in this case, I'm looking at a alpha of 0.01 and a confidence level of 99. So back to a hypothesized mean of 3 pounds, but this time at a 99% confidence. Hit OK. What do I have here? If I'm looking at this, well, now I'm back to that p-value, 0.019, right? 0.019. My p-value is less than 0.05, so even at the 99% confidence interval, I'm still going to accept that you can lose at least 3 pounds. So the main factors that I'm looking at here, my p-value, I can use the t-table if I wanted to and use a t-value. And if I was submitting this for homework, I would want my descriptive statistics box, and I would want my hypothesized testing box. So these are the main tools that you'll need when you're doing your case study and when you're doing your homework. And if you're having any confusion, I very strongly suggest you to join us on Thursday morning at 9 o'clock, where I will do some more Minitab examples. In the meantime, stay healthy. Let me know if you have any questions, and have a great day.